Good morning, students. We're here and we're proving angle relationships, and this is phase 1. So we're going to spend 2 days doing this so we can refine our skills and get really good at it. All right. So everything we've been talking about, from the alternate exterior angles congruence theorem, the AIA, CIA, all that great stuff, we're actually going to prove that to be true. And again, that's something I really appreciate about geometry, is that the teacher doesn't tell you something and you accept it as fact. No, we tell you something and then we sit down and we prove it to be true. All right, we show that it works for all cases, which is really powerful. It's a really good skill to have because you have to be clever. You have to use critical thinking skills, problem solving skills, all that great stuff. So first we're going to start with the corresponding angles postulate. Right? If two lines are cut by a transversal, so I'm right here. If two parallel lines, remember this is always a big punchline. Two parallel lines are cut by a transversal, then the corresponding angles are congruent. And recall, this is a postulate. All right. A postulate is something we just accept as fact. So looking down here really fast, I'm going to erase this eventually. But 1 and 3, their corresponding angles, if these lines are parallel, we accept as fact that they're congruent. All right. Because we can't actually prove everything in math. What do I mean by that? If you try to prove everything, you'd eventually have to run into circular reasoning, and you'd be using stuff to prove other stuff, but you haven't proved that stuff yet. So not to get overcomplicated, but so with postulates, they're kind of like the foundation. We're going to start here. We're going to accept this as fact. And if we accept these things as fact, we can prove some really cool things. So we're going to start off with the alternate interior angles theorem. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. And again, a good habit to get into, it says given lines are parallel. Remember, this is the notation. This reads an N line N is parallel to line P. Remember, that's what that notation reads. Anywho, all right, we like to draw on our pictures, all right? So I'm going to note that they're parallel, all right? So statement reason, first reason is given, all right? Now in statement 2, I'm saying 1's congruent to 3. Actually, I already talked about this. Actually, let me not circle it and put the congruent marks. Be a little bit more official. 1 and 3 are congruent. Why? Of the corresponding angles postulate. All right. And sometimes you'll see the word cap. At the beginning, I try to write corresponding angles postulate a lot, just so you know what it means, but eventually you can write cap, it's okay. Anywho, something I said earlier, 1 and 7. Why are these angles congruent? Again, we talk about so much you can't miss it. All right? We got these two lines, they're intersecting right here. Why are angles 1 and 7 congruent? Well, they're vertical angles. It's the vertical angles congruence theorem. All right, we can't forget about vertical angles. We use them so much. You have to be good at identifying vertical angles. All right. And then furthermore, again, this is a new proof, but it's a lot of familiar stuff, such as like angle 3 is congruent to angle 1. Angle 7 is congruent to angle 1. So 3 and 7 are both congruent to angle 1, so they're congruent to each other by transitive. And that's it. All right. So we just proved a pair of alternate interior angles congruent. In this particular case, it was angle 3 and angle 7. All right, and that's very powerful. All right, good stuff. Next, we're going to do the alternate exterior angles theorem, and this is going to look a lot very familiar. All right, what do I mean by that? Stay tuned and find out. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So given N is parallel to N. So let's go ahead and draw that. Given. All right. And notice how last proof I gave you all the statements, you had to do all the reasons. This time I only gave you 2 statements, so I'm being a little bit of a jerk. Why would I do that to you guys? That's not fair. I should just give you everything. Why is 1 congruent to 3? Well, again, they're corresponding angles postulate. And again, you might see cap. All right, now let's think. When we do proofs, we're eventually gonna have less and less information and we're gonna get better and better at it. All right, what's the punchline? We need to prove alternate exterior angles are congruent. All right, we need to prove alternate exterior angles are congruent. Well, 1 is an exterior angle. Well, so is 5. So how can I introduce 5 into this? Well, let's just say angles 3 and angle 5 are congruent. And why are they congruent? Again, can't miss this. They're vertical angles. Okay, so now I'm getting to the punchline. You guys probably can figure out what's going on from here. 1 is congruent to 3. Angle 5 is congruent to angle 3. So angle 1 is congruent to angle 5 by transitive. So very similar. Those proofs are almost identical, but they aren't. Cool beans. All right, let's prove the last one, and that will be the end of this particular video. The consecutive angle or consecutive interior angles theorem. If 2 parallel lines are cut by a transversal, then consecutive interior angles are supplementary. So we're given N is parallel to P, given. All right, now angle 1 is congruent to angle 3 by corresponding angles postulate. And again, if you're writing cap, I know what that means. We don't want to abbreviate every single thing, but we can abbreviate some things. All right, corresponding angles postulate. All right, and then saying definition of congruence. Now, reason 3 is definition of congruence. So if I look at statement 2, I'm talking about the angles being the same. Well, let's talk about their measure being the same. Well, that means measure of angle 1 equals the measure of angle 3. All right, and then in this proof, I'm being very precise. We're talking about how 1 and 2 form a linear pair. Sometimes you'll see this in proofs, just depending on who makes the proof. And why do they form a linear pair? By definition of linear pair. All right, so since they form a linear pair, we know that angle 1 and angle 2 by the linear pair postulate are supplementary. Remember, I'm not a big fan of the linear pair postulate. I think it should say that if 2 things form a linear pair, then they add up to 180 degrees. However, the linear pair postulate says that if 2 things form a linear pair, they are supplementary. So it kind of adds an extra step. I find it somewhat annoying, but that's the way we got to do it. But I guess at the end of the day, we're just being very precise, which isn't necessarily a bad thing. And again, buzzwords, since they're supplementary, I'm going to say measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I know that by the definition of supplementary. Cool beans. Next. All right, I'm getting close to the punchline. I need to do substitution. How am I going to do substitution? Well, angle 1 equals angle 3. So where I see this angle 1, I'm going to replace it with an angle 3. Measure of angle 3 plus the measure of angle 2 equals 180 degrees. All right. And then since they add up to 180 degrees, the end, the punchline, I can say, well, angle 2 and angle 3 are supplementary. And again, remember to buy conditional statements. That means we can go back and forth. Supplementary is a valid definition, is a very strong definition. So when things are supplementary, we can say they add up to 180 when by definition of supplementary. That's what we did in 5 and 6. Since they're supplementary, they added up to 180 by definition of supplementary. And we can go in the other order. Well, since they add up to 180, they're supplementary by definition of supplementary. So remember, the valid definition, stuff that's really strong, we can go either direction. Supplementary is a good example how we can go from 180 to supplementary or supplementary to 180. All right, that's it for this video. Stay tuned for more.